All right. So we have been talking about adding and subtracting fractions. And then before that, we were talking about multiplying and dividing. Tanner. Today, we are going to solve some equations using fractions. So let's talk about this just for a moment. If I told you to solve for x right here, what would you do? Minus 2 and divide by 3. And when I put 2/3, nope, minus 2, 4 minus 2 would be 2. So if I put 2/3 back in for x, what am I going to get? A true statement. So 2/3 times 3 would be 2, and 2 plus 2 does indeed equal 4. So 2/3 is the solution. Are you with me? Now this right here is important in what I'm about to show you today. If I put it in, it gives me a true statement. All right, and you did this in 7th grade. Then you did it in 8th grade, and you've done it in 9th, 10th, and now you're doing it again in 11th. And you did all kinds of different days. Like when you first seen this, you probably spent 2 weeks on these things. Okay? So let's talk about this one. How would I do that one? Minus 4 first. Multiply by 7. What would multiply by 7 do? It gets rid of this 7. Then I divide by 4. Any questions? No. All right, so then you know your teacher threw one fraction in. Then the next one. What would you do right there? Can I add 5, 6? Yeah, that's what we did over here essentially, right? So I could add 5, 6. Who wants to add 4 and 5, 6? Well, 4 and 5, 6 is just that. 4 and 5, 6 is a mixed number, but your teacher usually told you to put that in a fraction form, right? Look at that. I don't want you to talk. I want to give you about 15 seconds of silence. I want you to look at it and see if you could do that problem in an easier way given that right there. Essentially, that I can put the x on the top. Let me write it this way. Look at it for 15 seconds in silence to see if you can find a way that would prohibit me from adding 5, 6. Not prohibit, but help me not do that. You got an idea, Dakota? Austin, self? Jeter? Which ones? These? What's the LCD of 3 and 6? 6. So if I change this to 6, I could do that, right? What? Right, I can, if it's in the middle, I can put it on top. Why does that help me? Because 3 to 6, I would multiply by what? 2. So I multiply so I would get that, and then I didn't do anything to this. Have I changed the problem? I've changed visually, but not not quantity wise. Because 2/3 is equivalent to 4/6. Does that make sense? So now what could I do to this side, Tanner?
Well, if you add 5/6 to the answer,
Nope.
and then multiply that side by 6,
You can do that.
both sides will be multiplied by 6, and then that 6 on both sides will cross out.
Okay, Tanner's a little bit ahead of the curve here. Tanner, hold that thought for just a moment. Since we've done this, what can I do on this side? 4x minus 5 over 6. Do you see how I can combine that with the knowledge that you had the past 2 days? Now what could I do? Multiply by 6. Because now what will happen to these 6's? So I have 4x minus 5 equals 24. Is that not more pleasing than taking 4 and adding 5/6 to it?
Yes.
So what do I do now? Add 5 and then divide by 4. Who has questions? Yes. All right, what was the problem I just had? Here we go. I'm going to do it a different way. What can I do to a problem if it has an equal signs? Absolutely anything that I want to, as long as I keep it equivalent. So this right here, I kept this equivalent because I changed the fractions. Right? Now, what could I do to this problem? Let me ask you this. Could I add 2 to both sides? Yeah. Why? Guys, look at me. I know that you're not, I know this is not like exciting stuff, but we got to get through it, okay? So, can I add 2 to both sides of an equation? Yes. Why? Because if me and my husband are standing on the side of weights and we weigh exactly the same amount, if someone throws me a 2-pound ball, that would be 2 pounds added to my side, right? How do we stay balanced? Someone has to throw him a 2-pound ball, and then we'd be balanced again, right? So if I add 2 pounds to this side and I add 2 pounds to that side, would that be equivalent? Yeah. Yep. Now, what if someone comes through and multiplies my weight by 5? Well, if me and my husband weigh the same thing, what would they have to do to him? Multiply him by 5. So if I have this weighted thing here, and I'm saying that these are weighted, the 2/3 x minus 5/6 weighs the same as what? 4. So how do I keep those equivalent? I can add something to both sides. So that would be 2/3 x minus 5/6 plus 2 pounds, and then 4 plus 2 pounds. Or how could I multiply and be the same? Can I multiply this side by 5? And multiply this side by 5. Why does this side need parentheses? It's the whole thing. This is what equals, right? So that 5 would have to be distributed. Are you with me? So 5 times this quantity and 5 times this quantity. Because that quantity together would equal 4. All right. Here's the hard part. You've been taught this. I want my problem to go as smoothly as this, where I get rid of the fractions somehow. How can I get rid of the fractions here? Tanner, don't talk. How can I get rid of these fractions? By doing something to both sides. Huh? Multiply by 6. Why? It's the least common denominator. If I multiply this side by 6 and this side by 6, what do I have to do with that 6? Distribute. So watch me. 6 times 2/3 with an x on it minus 6 times negative 5/6. Are you with me? Oh, sorry. That's not a negative. Just 5/6 because of minus, right? And then equals 24. How do I do this right here? 6/1 times 2/3 would be what? 12/3, which is what? 4. Then what would this be? 5. 30/6, which is 5. What's happening with those 6's? Right? They're multiplied, so they cross out. And then what happened with that 6? It broke down to 3 and 2, and the 3's crossed out. Solve for x. Is that the same thing that I got a while ago? Yep.
That's not what I was thinking.
It sort of was. But hold on just a minute, Tanner, because you told me to add 5/6 over here. So if I added 5/6 over there, I would have got 29/6. And then you told me to multiply by 6. 4x equals 29. Divide by 4 is 29/4. You are doing the same thing, but since I'd already had this set up, with those being the same, I could put them together, and it looks like it would be less work. But if these are the same, Tanner, they would go away because they would both cancel out. So essentially, that's what Austin Buckner told us to do, multiply by 6. Jeter?
Can there be fractions inside of fractions within fractions?
Yes.
Okay.
Yeah. Yep. 1/3 plus 2/4/7 plus 5/6. Yeah. Well, you would take it one at a time. So the first, if I told you to simplify this, you would do this first. And well, what's 2 divided by 3/4? 2 divided by 3/4. How do you do that? No. Oh my gosh, no. Y'all should not graduate if you can't do 2 divided by 3/4.
What?
1.25?
What do you do? 2 times 4/3, which is 8/3. Then you do 8/3 divided by 7/3. Get that answer. And then you do that answer. Then you would do this one first. And then you'd get that one fraction and add it to this one fraction. And then you would take that one fraction when you got those together and divide it by that fraction. All right, here we go. So solve for this one. Let's make it easy. Why would I times everything by 28? That's the least common denominator, so everything is going to go into it. So watch this because it's going to get more complicated immediately following this problem. So 28 times 4/7, you would do 28 times 4/7 x plus 28 times 3/4 equals negative 2/7 times 28/1. Are you with me? Where did I get 28 from? 7 and 4 and 7. What's the LCD of 7, 4, and 7? 28. Why did I put the 28 over 1? Just to show you that it's equivalent. Do I need it? No. But when I'm doing it over here, I might need it as well. Why didn't I just do that to mess with y'all sometimes? In a good way, because you got to see that those are equivalent. Just as I put a dot here and a parentheses here. Same thing. All right, let's do it. 28 times 4 sevenths. Do we want to do 28 times 4? No. 28 times 4 sevenths. Does everybody see how that would be 28 times 4 over 7? What does the 28 reduce to? 4 and 7. Then what would happen with the 7s? So this is going to be what? Look at my shortcut. 7 into 28 goes how many times? 4. 4 times 4 is 16. Look at this. 28 times 3/4 would be 7 times 4 times 3 over 4. What goes away?
21.
So 21 is your answer. 4 into 28 is how many? 7. 7 times 3 is 21. Right, what do I do here? Negative 2 sevenths times 28. Negative 2 times 7 times 4 over 7. 7's go away. Negative 8 is my answer. Any questions?
Minus 21.
Who got lost? Savannah's the only one? Ryan, do you understand this? Dakota? Austin? Savannah, where'd you get lost? Well, how did I get the 28? We'll do one more, Savannah. Who stayed with me on that one? Okay, so then what do I do? Minus 21. Is everybody good with that? And then divide by 16. All right, let's do another one. Sorry, let me change this. That's a 5. All right, here we go. What would I multiply
12.
to get rid of the fractions? 12. Why 12? Did you say 12, Savannah? Why? 6, 3, and 4, all three of those go into 12. So if I multiply 12 times 5/6 plus 12 times 2/3 x equals 12 times 5/4. 10. How am I getting 10?
8 on the next.
Watch. Guys, we just did this week. 12 times 5/6. Put a 1 over this. And that would be 12 times 5 over 6. Because it's multiplying, I just squish them together. What does the 12 reduce by? A 6. You with me, Savannah? What goes away are the 6's, which leaves me with 2 times 5, which is 10. Here's the shortcut, Savannah. 6 into 12 goes how many times? 2 times 5 is 10. 3 into 12 goes how many times? 4 times 2 is 8. And then what's this one going to be? 15. Are you with me? Minus 10 divided by 8. All right, here we go. Write this down on a clean sheet of paper. Not your foldable yet. Not your foldable. That's fine. Guys, write that problem down. Let's go. Oh, this is a terrible problem.
Agreed.
Put an X on the 5. All right. Do I have fractions? Well, let's get rid of them. Multiply by
X minus 3.
y. That's the LCD. What's the denominator here? X minus 3. X minus 3. X minus 3. So the LCD, if they're all the same, has to be.
X minus.
So watch this. This is a little bit of overkill for some of you, but not for some of you. X minus 3 times this one plus X minus 3 times the second fraction equals X minus 3 times the other side. Guys, what is this? Multiplication. So these would squish together, and these would go in parentheses because they're binomial. What happens to them? Cancel. What does this one do? Cancel. What does this one do? So I have 4 plus 5x equals 7.
Minus 4.
Minus 4.
3 fifths equals.
Who has questions? Now, guys, here was what I told you was important on these. Monica, I'll go back. I see you're still writing. Do you remember my very first problem when I got my answer and I put it back in and it gave me a true statement? Yes? Look at this. You have to check your answers. Here is why. If I put 3/5 in for x, what could I never have on the bottom?
Zero.
What am I not supposed to have on the bottom? 0.
Yeah.
So does 3/5 putting that in for x, does that put zeros on the bottom anywhere?
No.
So this is a solution.
Boom.
You with me? That's not too bad, is it? All right, here we go. Cheater. You stop doing that. Shh. Shh. Guys, stop moving and talking and write this down. All right. I have fractions here. So let's get rid of them. How do I get rid of a fraction? By the LCD. So
X minus 2 times X minus 1.
do I have to have 2 of these X minus 2s? No. All right, so here we go. Does everybody agree that my LCD is X minus 2, X minus 1? So, okay, here we go. X minus 2 times X minus 1 times
X minus
4 over X minus 2 equals X minus 2 times X minus 1 times 3 over X minus 1 plus
Whoa.
That ain't good. Uh-oh. I hope it's recorded.
X minus 1 plus X minus 2 X minus 1 times 5 over X minus 2. What am I doing there, guys? I'm multiplying each term by the LCD, which is what we've done so far in every problem.
Equals and pluses.
What?
You got the equals and pluses.
No, I don't. Now, once you get this whole line, go back. This is over 1. I can put it over 1 or I don't have to. But if this, Tanner, if this is multiplying, it would all squish together, and what would go away? X minus 2. So what do I have left? 4 times the quantity x minus 1. What goes away over here? So 3 times x minus 2. And then what goes away over here? So plus 5 times x minus 1. No, don't divide by 4. Now what would you do to solve for x? Distribute. 4x minus 4, 3x minus 6, plus 5x minus 5. Tanner, it's not wrong to divide by 4. It just makes it more complicated in some cases. Now, what would I do? I'm going to leave the left side the same, and 3x and 5x would be negative minus 11. Then what? Add 4. No. Add 4? Okay. You can do either one of them. Well, I would subtract 4x. Because if you move your variable first, you can kind of pick when it's positive. So if I move my 4x over, 4x minus 11, and then my x is always positive, so I wouldn't have to divide by negative. Then add 11 to get 7.
Divide by 4.
What do you have to check?
Plug it in.
Plug it in. 7/4 is your answer. If I put 7/4 for these x's, would I ever get 0 on the bottom? No. Yeah. I want you to look at your foldable, and I want you to do example 1. Right now, I want you to do example 1. Austin, do you have a question on this one? Okay. How do I get rid of fractions? Multiply by the LCD. What's the LCD? Yep. So everybody got this? What would go away? And then why did I switch the order there? Because monomials usually go in front of the binomials.
3. Add 40. 15. Right about now. Holy cow.
What do you have to check on these? You have to make sure that your answers don't make the bottom 0. So if I put 3 into that original function, does it make the bottom 0?
I've done this one.
No.
No.
There's a lot of you.
Yeah, I've done this way wrong.
I just cross multiply.
You can.
I get it.
Not on example 2, it's not.
I get it.
Or excuse me, not example 2, but like example 3. Jordan, example 3, you can't cross multiply. All right. Jordan did bring up a point. Monica, hold on just a second. Do you see how this is a fraction equal to a fraction? I can cross multiply. Do you see how it's one fraction equal to another fraction? Not, are you listening? Not like example 2 on your foldable. But look what you could do. If it's a fraction equal to a fraction, you can cross multiply. 20 times x and then 5 times 3x minus 5. Is that not what we got at the end? Oh, yeah. But you can't do that on example 2 or 3. What was your question, Monica? Do example 2, please. Tell me when to stop. Right here. Did you get here? So you have to get your x's. Guys, you should be working on example 2. So this right here, Monica, if you got here, you have to get your x's on one side and your numbers on the other. So what can you do? You could subtract 20x, you could add 25, or you could add 40. Doesn't matter what you do. Did you have me for math 1? I always taught you to move the variable first, but move the one that would make the other side positive. So meaning, if I move the variable to one side, I could either subtract 20 because there's a positive here, or I could subtract 15 because there's a positive there. And I would subtract 15 over here because that leaves me with the 5x. If I subtract the 20, I have a negative 5x. Does that make sense? Then what would you do? Add 40 because you're trying to get that x by itself. Add 40 and then divide by 5. Once you add 40, you would get 15, and then you would divide by 5. Did I get x equals 3 a while ago? All right, guys. Example 2. Katie, you getting this? All right, Kelly, what do you do on number 2? Which is?
3x.
You're not Kelly. LCD is 3x. So you do 3x times, shh, guys. You do 3x times all of these. What goes away in this first one? X's. So I would have plus. What goes away in the next one? 3's.
Minus 40.
Move on to example 3, Tanner.
Huh?
Example 3.
Oh, I don't finish that?
I will in just a second. Go.
Oh.
Who has questions up into that point? All right. Now subtract 24. Is -6 the true solution?
No.
Why, no?
Does it make the bottom of a fraction 0 when I plug it into the original problem? No. So is it a solution? Yep. Who has questions? -6. Shh, boys. If I put -6 in for x in the first equation, it does not give me 0 on the bottom. Therefore, it's a solution. All right, do example 3. What's the LCD? X plus 3, x minus 4. Do I need a 2? That's not on the bottom. A 1's on the bottom.
This is how Parsons think 2 times on this. Should have to add.
Who has questions? Oh, what did I forget? I forgot my 2. So I hope that y'all see that these are just being drugged down. Who has questions? What gets marked out? X plus 3. I have x minus 4. Now pay attention. I have to put the 3x plus 5 in parentheses. What gets marked out right here? Nothing. Times 2. Plus, what gets marked out right here? Both of them. So it's plus 8. I'm not going to finish that one because the bell's about to ring. Your homework tonight is to study for your quiz. Do not lose this sheet of paper. We'll finish it tomorrow.